Okay, so question 1, the first question, part A, asks you to factorise. So the first thing is just realising that factorise means you've got to put it so that you've got brackets with the common factors in front. So let's put some brackets in. Now if I'm looking at this, what's the biggest number that goes into this term and this term? Well, because the first term doesn't actually have a numerical value, there's no number, there's no common factor that's numerical that can come out in front of the brackets. But y squared and 27y have both got a y in them, so the y can come in front. So you factorise it, you've taken the common factors out in front, and now think about expanding brackets. Y times by what gives you y squared? Or y times by y gives you y squared. Y times by what gives you 27y, or y times by 27. So this, if you expanded it, would give you this. So this is the fully factorised version of this expression. Part B, if you ever see things like this where you've got brackets and indices, this is the situation where you're going to multiply your two indices. So 3 times 2 gives you 6. If you're a bit unsure about that, t cubed is t times t times t. So if you're squaring t cubed, you are timesing t cubed by itself, hence t to the 6. It's t cubed times by t cubed. Okay, but in short, with this rule you just times these two. If you're, this is a bit of a side note, it's when you times two different values with indices like this that you would add your indices. So they're not directly next to each other like you have in this situation. So this is the situation where you would add your indices. So this is just another way of saying divide. It's exactly the same as saying w to the 9 divided by w to the 4. So we subtract our indices, which gives us w to the 5. Okay. Went a little bit off screen, but that's what it should look like. Let's just do question 2 at the same time. Alright, the diagram shows a square with a perimeter of 16. Now if it's a square, you know all the side lengths are the same. And if the perimeter is 16, you know that all of the sides must be 4 centimetres, which immediately allows us to fill in a lot of these gaps. So if that's 3, this top bit must be 1. Okay, work out the proportion of the area inside the square that is shaded. Okay, so what proportion of it is shaded? Well, if we work out the area of the full square, (4 centimetres times 4 centimetres gives you 16 centimetres squared. The easiest way to get the area of the shaded region, because it's a bit of a weird shape, is actually just to do the area of the full square again and take away the white bits, which is just 2 triangles. So the shaded area is the full area, which is 16, but we're going to take away the area of this triangle. Now I'm going to do this in shorthand because it's a sort of basic mathematical concept. Base times height and then half it. So 4 times 2 is 8 and half it. The area of this little triangle is 4. So it's 16 minus 4. And take away this bit as well. So again, base times height, 1 times 4 is 4, but we half it because it's a triangle. So the area of this bit is 2 centimetres squared. So it's the full square, but we're taking away the 2 centimetres squared and the 4 centimetres squared. So 16 minus 4 minus 2 gives you 10 centimetres squared. Work out the proportion of the area inside the square that is shaded. Okay, well it is 10 out of 16 centimetres squared. That can be simplified to give you your final answer.